Okay, so in this section, we're going to do perfect, cube factoring. And so the key to this is to figure out what does A and B equal. Because once I can figure out what A and B is equal to with what I'm given on the left-hand side, then I just substitute in everywhere I see my A's and my B's. Okay, same thing for a difference of cubes, or a sum of cubes here. So the first one's the difference of cubes because of the subtraction, and then the sum of cubes has the addition. But again, all I'm trying to do is figure out what does A and B equal, because if I can figure out what that is equal to, then I can factor it. Okay, so in this case, I need to figure out, okay, so the cube root, so what times what gives me x cubed, and that's x, and then what times what gives me 125, so b is 5, because 5 times 5 times 5 gives me 125, so x cubed plus 125 factors to x plus 5, x squared minus 5x plus 25. So it's a plus b, a squared minus ab plus b squared. Okay, and you will always look for a greatest common factor. So this can pull out. So this 4x cubed minus 4 factors to a 4, and then an x cubed minus 1. Now my a is equal to, not 1, x, and my b is equal to 1. So this factors to 4, x minus 1, x squared plus x plus 1. Okay, because the difference of cubes is a minus b, a squared plus ab plus b squared. Okay, so now if I have something different, like this kind of looks like a difference of squares. So this kind of looks like, because it's to the 4th power. So remember when I had my x squared minus 25, right? That factors to x minus 5 and x plus 5, which it doesn't make any difference whether I write the addition first or the subtraction first. Now if I had x squared minus 25 squared, then this would have factored to x squared minus 25, right? And x squared plus 25. Okay. This simplified would have been x to the 4th, and this simplified would have been 625. And so what my original factoring would have looked like was this, and I would have been expected to get this, but there's a but my x squared minus 25 factors to a difference of squares of x minus 5 and x plus 5, but my addition of the square does not factor to anything like a difference of squares. There's no sum of squares formula, okay? So this would be the fully factored form. So now, when I do this, this is the same thing as x squared, and this is the same thing as 16 squared. So x to the 4th minus, my hand is just not writing correctly today, x to the 4th minus 256 would be an x squared minus 16 and an x squared plus 16. The plus 16 one does not factor anymore, but the other one is a difference of squares of x minus 4, x plus 4, and then I just have the x squared plus 16 to tag along in the end. Okay. Same thing here, 81 n to the 4th minus 1. So this would be 9n squared minus 1, and 9, that looks like an A, 9n squared plus 1. And then this subtraction, so this n squared minus 1 would factor to a 3n minus 1 and a 3n plus 1 because of difference of squares. And then I have n squared plus 1. Okay? Now this 8th power is a little bit weird because it's really like, 8 x's that are together. So when I factor this is 16x to the 8th minus y to the 4th. So I'm going to take that square root, so I get 4x to the 4th minus y squared. And then I'm going to have a 4x to the fourth plus y squared. And now this other factor here does not factor anymore, but this first one factors more to a difference of squares. So this is 2x squared minus 1 and 2x squared plus 1. And then 4x to the fourth plus y squared. And I'm going to leave it like this. In theory, I could actually factor this a little bit more with some square roots, but we're not there yet. We haven't really talked a lot about square roots other than a previous class, so we're just going to leave it for right now. Okay. Now, these ones that have 3 terms, this looks very, very similar to my x squared plus 4x plus 3 situation, right? Where I have my x, and then I had my 4 up here, my 3, and it's 3 and 1, right? And so I'd have an x plus 3 and an x plus 1. Well, this factors the same exact way. The only difference is that when I draw my x, right, I'm going to put my 4 on the top, my 3 on the bottom, so it's still 3 and 1. But instead of x squared turning into an x, this x to the fourth is going to turn into, an x squared plus 3 and an x squared plus 1. And then because there's no sum or there's only a difference of squares, not a sum of squares, then this is my answer here. Okay? And we don't need that anymore. Okay, so now my 9x to the 6th, 12x cubed, and 4. So I'm going to do my little thing. I put 12 on the top, 36 on the bottom, so my 2 numbers are 6 and 6, because factors of 36, 1 and 36, 2 and 18, 3 and 12, 4 and 9, and then 6 and 6. Now remember, when I have a number in the front, I have to do bottoms up. So this is going to be x cubed plus 6, and I'm going to divide it by 9. And then x cubed plus 6, and I'm also going to divide that by 9. They are the same term, so I'm going to reduce. So x cubed plus 2 over 3, x cubed plus 2 over 3. Bring what's in the bottom to the top. So then I get a 3x cubed plus 2 and a 3x cubed plus 2. So I get a 3x cubed plus 2, the quantity squared. Okay, I'm going to rewrite this because it looked a little messy here. Okay, and that is it for this lesson.